So now we're going to actually apply logarithms a little bit. We talked about logarithmic form and exponential form, and now we need to actually show you what the purpose of logs really is. Okay, and that is to solve equations when we have variables as powers. Now in 7.2, yeah, we were able to change the base so they were the same, and then we could just line the powers up and solve those. But that doesn't always happen, and so that's why we need logarithms to solve equations when I have variables as powers, when I can't change the base to be the same thing. So that's what this is for, okay? We've got two different cases that we're going to look at. Our first case is going to be problems like this, where there is just one log, okay? When there is only one log, you just have to rewrite it in exponential form, and then you'll be able to solve it, okay? So start by writing this equation in exponential form, bless you, and see if that gives you enough information to be able to solve. Raise your hand if you've got it in exponential form right now. Alright, then I'll wait a little longer till you get it there.
9 to 3 halves.
Yep. Very good. Hopefully you got, how many had that? Good. So what is 9 to the 3 halves? Okay. So if I take the square root of 9 and cube it, that is cubed, which is 27. Do a quick little check, make sure we don't have a negative here. It's not negative, we're good. How many had that? Okay, so that's it. For one log, rewrite it in exponential form, simplify. Okay? Now, the other type of problem that you're going to see today, there's going to be two logs. Question? No? You're good? Yes? Okay, good. Alright, let's look at another one. Oh yeah, there we go. That's the answer. Alright, so when I have two logs, your goal is to basically cancel the logs out and solve. So in this case, and the other thing that's important, and you won't see it this way yet, eventually we'll get there, is it has to be log with the same base. And these are both log 3. And I have log equals log. That's good. So I just need to set this equal to this. So go ahead and solve that now. Not so bad. Make it equal to 0. Then what do you do from there? Factor if possible. Is this factorable?
Yes.
You betcha. Factor it for us.
X plus 3 times x minus 5 is equal to 0.
Good. Or the other way, which is fine. Same thing. Maria, what are the solutions then?
It'll be x equals -3 and x equals 5.
Very good. Okay, how many got those for solutions? Is that it? You're done? What else do we have to do real quick? Plug back in. Let's check it out. Okay, so let's check this first. Okay, it's really important to check your answers, especially when you start seeing negatives come in. Okay, when you see negatives come in, well, not even necessarily. The problem is this can't ever be negative, this can't ever be negative. Okay, so if that ever happens, then we have to throw those solutions out. So let's start with the 5. We plug it in, and this is 5 squared minus 15, which is what? 10. And 2 times 5 is 10. So that's good. They equal each other. So 5 is definitely a solution. Okay, that one checks. Question?
Do we have to plug it in? Like, is it like
Yes, you have to. Yep, you have to. Because of what's about to happen. Okay. So when I plug in -3, this is 9 minus 15, and then over here I get -6. So even though it looks like, oh, it's all fine, right? Log base 3 of -6 equals log base 3 of -6. It seems like it should be okay. The problem is you can't ever raise 3 to a power and then it turns to a negative, which is why we're not allowed to have negatives here. Okay, that's where our problem becomes. Right? Because with logarithms, that number can never be negative, just the same way that this number can never be negative. So what that means is I throw out -3 so that is actually not a solution. So when you're solving logarithmic equations, this can happen, which is why you do have to check and plug it in, okay? If everything works out like it did over here and I have positive numbers and they equal each other, then it's fine. Alright, and you can keep that one. Over here, we'll have an issue. On the first one, if you noticed, we did a quick little check. I'm like, 27, I could put that in there, it's good. This one you're going to want to show it, okay, and be sure. Any questions?